The theoretical probability and theoretical frequency are calculated. Theoretical, which is nothing but expected frequency. In the Poisson distribution, average is equal to lambda, or lambda is equal to np, okay, or x bar. So in the question it is clearly given lambda value is given 2. The theoretical frequency x is equal to 0 because the Poisson variant we need to select. Hello everyone, a warm welcome to one and all. I am Natesh, lecturer in commerce, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. We are in the Unit 3, Section 10, third semester BCom, probability distribution, and today my agenda under Poisson distribution. In the last session, which is related to the complete theory part, now we are trying to go for solving the problem, okay, using the probability mass function. So here once again the definition which is related to Poisson distribution. So a random variable, which random variable means which is a discrete random variable, okay. So under x is said to be follow Poisson distribution if it probability mass function given by any examples which is related to the Poisson distribution examples. So we are trying to go for mass function. So the formula is very simple. So x is which is nothing but a discrete random variable. So from this experiment will start from the 0. So we are writing p of x is capital letter X is equal to small letter x. The probability mass function here e to the power of minus lambda, e to the power of minus lambda, Euler value. So here minus lambda into lambda to the value of x divided by x factorial. So the lambda under Poisson distribution, no doubt which is a mean, okay, or average you can say. So if you try to extend, np is nothing but your mean, okay. So the small variant which is nothing but the Poisson variant, okay, when you are writing a small letter x which is related to Poisson variant. So always the lambda will be the value whenever you are trying to consider which is always greater than 0 only. So with the parameters when you are trying to select the property which is completely lambda value or mean value. So here x is a Poisson variable variant, which x or capital X or small letter x which is nothing but your Poisson variant. So E stand for Euler constant value always which is a 2.7184 which is a Euler value, E value. So symbolically P, okay, which is approximately P of lambda. So x is a discrete random variable, so the P of lambda value. The probability functions of Poisson distribution is given by always which is starting from the numbers. So we are writing P of a discrete random variable under Poisson variant. So e to the power of minus lambda which is a standard formula into lambda to the power of x. So x, you know the x value which is based on the experiment. So here x can be a 0, 1, 2 till the numbers, okay. So here the x which is continue from here, and E of x which is nothing but arithmetic mean. So mean is equal to lambda, lambda always equal to mean. If you try to extend when you are writing lambda, so NP also we can consider in the Poisson distribution is a lambda value as Poisson arithmetic mean value. So the variance V of x which is nothing but variance is equal to lambda is equal to, both are same, okay. In case of variance which is always equal to lambda. So when you try to get a standard deviation inside the square root, if you write mean, okay, or lambda if you write, lambda is nothing but your mean value. So which is if you are writing inside the square root, that is it will give you the standard deviation value. So moving, there is one question, the average number of telephone call, the telephone call which is related to Poisson distributions problem, okay. The best example here, the telephone call. Calls of telephone operator receive per minute between, the time is clearly specified. So 9 to 9:05, so 5 minutes duration. So how many calls they received, the telephone operator, okay. So here the average what you are identified, so which is nothing but lambda value is given in the question which is 2, okay. So once again the average they specified. So in the Poisson distribution average is equal to lambda, or lambda is equal to np, okay, or x bar. So in the question it is clearly given lambda value is given 2. Find the probability that during one particular minute. So now we are finding a difference, there is 5 minutes. So if the question is which is related to 1 minute. So she does not, maybe you can assume the telephone operators, those who are receiving a call, okay, she is a girl, so that's what, she does not receive any call at all. Okay, does not means what? So from the X variant, which is starting from 0, 1, 2, so till the number. So does not means 0 is best. Okay, so the suitability here, the according to question 0, because she is not receiving any call means 0. So in this case, given e to the power of minus 2 value, because in the question average is 2 specified, the value is clearly given in the question, so we need to consider this one. So moving forward, so we need to identify which is event. Now we are setting for, let X be the number of telephone call received by the telephone operator. So in the questions, according to questions, we are setting an event. So now the moving for probability mass function, the same formula, given P of X, because we are trying to do for discrete random variable under Poisson variant. Small x is a Poisson variant. E to the power of minus lambda, lambda to the power of x divided by x factorial. So which is starting from 0 till the numbers. Okay. So the she is not receiving any call means we need to select a 0. So the probability, if you are writing in the statement wise, okay, the probability of she does not receive any call. So instead of writing a statement, so directly we can write the Poisson variant is a 0 because she is not receiving a call. So e to the power of minus lambda, lambda value we know because they specified in the question average. So we are writing a minus lambda place, we are writing minus 2. And lambda place we are writing 2 to the power of 0 because she is not receiving call. So 0 factorial. Anything if you write to the power of 0, which is always giving 1 value. So when divided by denominator, 0 factor is nothing but 1 value. So now finally we in the question, the value e to the power of minus 2 value which is given in the question, so which is always equal to lambda value. So the P of X, she is not receiving the value. Okay, now the statement what you are writing note, that is the probability that the operator does not receive any call at all. So which is giving in the question 0 point, which is equal. Okay, so moving forward for next question. There is one more question. It is known that the 3% of certain screws manufacturer, okay, certain screw manufacturer are defective. Now you have to identify defective which is related to Poisson distribution example. So the 3% of certain screw manufacturer for a firm defective. So the total production, so 3% are defective. Defective is the best example for Poisson distribution. So what is the probability that the defective screw will be found in the box of 100 screw? So here which is given, n is given directly. The probability P of P is given. So you know the lambda is in this case lambda is equal to NP. You have to multiply. So the P value, given value is given. So the fractions have written here 0.0. Okay. So n is a small letter. Number of box, how many numbers you are finding? Here 100 you are finding. So now from the question we need to set event. So we have identified X is a number of defective screw. Okay. Now immediately the probability mass functions in the Poisson distribution given by P of X is equal to X. Why we are writing X, which is a discrete random, and this one is a Poisson variant. So which is starting from the functions, okay, e to the power of minus lambda into lambda to the power of X divided by x factorial, because the starting value from the 0. Okay, so now we in the using this question information we need to find out lambda. Unless we don't have any lambda, we cannot go for further solving. So for that reason n into p. So n is given in the question 100 into 3 p place 3 by 100. If you directly cancel 100, now the lambda value is 3. Once you get the lambda value, now we are trying to go for finding the question which is related to defective. Okay, so the defective, the probability of a defective screw may be 1 or more. Okay, so there from the out of 100 numbers there will be a number of defective or you are able to identify. That's what the total probability in this case will be total 1. So in this case the P one defect, at least 1 or more defect you are finding. So that's what we need to write like this. P of 1 or more defective of screw. So when you are symbolically we are writing P of X, X is a variant, okay, which is greater than or equal to at least 1 defective or more than one defective. In this case, we are writing like this. Okay. So the total probability, the total manufacturing which is related, the total probability always you need to assume 1. So from this one, we need to subtract P of x minus 1, less than 1. So P of x, which is starting from the first, no, there is no defective which is starting from 0. So for that reason, 1 minus P of x is equal to 0. There is no defect if you assume. So the same thing, 1 as it is I am writing, because the probability mass functions will starting from the 0. So that's what e to the power of minus lambda, lambda value we got 3. Okay. So the functions we are writing, so the probability mass functions. Okay. So the total 1, whatever it is there, I am writing as it is. The value we know, the lambda value minus 3 we got. So the lambda place I am writing a minus 3 and 3 to the power of 0, 0 factorial, which is nothing but 1 is as it is I am writing. So e to the power of minus lambda value we need to find out, okay, using a scientific calci or directly table. Okay. So e to the power of minus lambda, in this case we are getting 0.0498. So from this 1 minus 0.0498, if you subtract, we are getting 0.9502. So which is nothing but there is at least one mistake or more than one mistake. So in that case, we are writing P of x greater than or equal to 1. So which is nothing but after subtractions value. So the probability of defective screw will be found in the box of 100 screw, which is nothing but 0.9502, which is the final answer. Okay. Moving forward, next questions. Okay, there is one more questions for any inspection of manufacturing product revealed 2 defective per unit. So a defective which is related to Poisson distributions examples. So we can identify with the help of examples also we can identify. So per 2 defective units. Okay. So use the Poisson distribution and calculate the probability of finding a product with 0 to till 6 defective, which can be extending. So given that e to the power of minus 2 value, which is given 0.1353, okay, direct value e to the power of, okay. So in this case, the 2 is a lambda value. So directly in the question, they clearly specified. So given whatever which is given, I am writing as it is, the lambda value is given 2. Okay, now x variant as Poisson variant, which is given in the question, 0 to 5 defective, which can be extending. If you are not getting the probability exactly, the total always getting 1. If you are not getting, so the defective will be extending. So, and the average number of defective which is in the questions, directly lambda value is given 2, directly we can write. So now we are going for the probability mass function, the probability of finding a product without any defective, which is nothing but 0, which is starting from the x variant, Poisson variant 0, ending with the 5th. It can be extending if you are not getting exact 1 total. So the defective P of x is a probability mass function. So we are trying to extend the formula, the e to the power of minus lambda, lambda to the power of x divided by x factorial, which is starting from the Poisson variant, the 0 to 5. Okay. So P of x is equal to x, e to the power of minus lambda plus we are writing 2. We know the value of 2. Okay. Now which is x factorial, the first series which is starting from 0. Okay. So moving forward. So the probability x series, whatever it is given, it can be extended if you are not getting the total probability after calculating, if you are not getting total. So in that case, the defective can be extending. So here the probability mass functions, the lambda value we know, okay, the which is starting from the experiment where P of x is equal to 0. So e to the power of minus lambda place we are writing minus 2 and lambda plus 2 to the power of 0, first 0 factorial. Anything power 0 we are getting 1 value, anything denominator 0 factorial we are getting 1. So for that reason e to the power of minus lambda value which is given in the question directly 0.1353. So directly we are writing e to the power of minus lambda plus we are writing. So 2 to the power of 0 we are getting 1, 0 factorial means 1. If you directly multiply, the e to the power of minus always equal. Okay. So moving for second variant, Poisson variant, which is 0, 1. P of 1, e to the power of minus 2 value we got direct in the question. So we are writing 2 to the power of 1 means so we are getting 2. So divided by x value which is considered 1. So in the denominator also we are writing 1. So the final, if you multiply, we are getting 0.2706. And going for the next Poisson variant 2, P of 2. e to the power of minus lambda plus minus 2, now 2 to the power of 2, because the lambda value 2 value is a 2, 2 into 2 4, 2 factorial, we need to extend like this. Okay, we are going for reverse, 2 into 2 4, the same thing which is constant for all the variant which is constant, e to the power of minus value constant value. Okay, so if you multiply, we are getting like this. See, 2 ones are 2 twos are, so directly now which is carrying for 2, so one more step I have carried here, and divided by what is left here, 2 cancel, now directly 1 we are writing. If you multiply, we are getting 0.2706. Moving for the next Poisson variant 3, e to the power of minus lambda value, which is a constant value, so we are directly writing 2 3 times. If you multiply, you are getting 8, and 2 3 times if you try to extend, 3x is a 3 value, no, so 3 into 2 into 1 reverse going. So now here 8 is a common, so 2 ones are 2 fours are, now 4 is we are writing. Okay, now whatever it is left, so we have to write like this. So if you multiply divided by 2, we are getting 0.1804. Now moving for the next Poisson variant is a 4, e to the power of minus 2 value is which is constant, 2 to the power of 4 means 2 4 times you have to multiply. So 2 4 times multiply means we are getting 16. The 4 factorial we can extend like this. Okay, the 16. So 4 ones are 4 fours are, again 2 ones are 2 twos are. If you what is left, so the 2 is the denominator as it is left, now 3, and denominator 3 and 1 is carried. So if you multiply and divide, we are getting 0.0902. And now next Poisson variant is a 5. Okay, e to the power of minus 2, which is a constant value, so we are writing like this. So 2 5 times multiply, we are getting 32. So 5 factorial like this. So we need to extend like this. So the 5 factorial, so again 4 ones are 4 eights are, 2 ones are 2 fours are. So what is carry remaining? So we are writing like this, the 4 and divided by 5 into 3. Okay, if you direct multiply divided by 2, we are getting 0.02. 0.0361. After adding all this, we are getting 0.9832. So because exactly the probability we need to get to 1. So whatever it is missing, maybe your defective can be extended for 6 or 7 till you have to get the total summation, you have to get 1. So that's what the defective can be extending here. So in this case, the total probability what we are getting the summation 0.9832 up to 5 defective. So it can be extending because the probability we need to get the total probability need to get 1. So that's what that means. Still there is a probability of 6, 7, 8 is required. You need to calculate the probability mass functions. Then only we can get for 1. Till 1 we are getting, we need to extend the defective. So till we got the total probability 1. Okay, so the defective can be extending. The above calculation can be simplified. Generally, if p of 0, because the functions will start from the 0 and lambda is calculated enough. So the rest of the probabilities can be found out shown below. So the p of whatever it is given in the question, so direct answer here, so which is lambda. If you try to cross check using a number, the value is same. The using a probability, we are getting lambda, both are same only. Moving forward for the next one. So fitting a Poisson distribution. Fitting a Poisson distribution, which is an expected question for the final examination. So obviously you can expect this Poisson distribution. Okay, fitting a 15 marks. A Poisson distribution has only one parameter, namely lambda. Lambda, if you try to extend, which is nothing but NP. If you try to extend, you can write like this x bar. Both are same, average. So this value determine the distribution. Okay, completely. Whenever you try to calculate the distribution, whatever it is required according to the questions, according to probability mass function, so we need to find out the lambda value. So to fit the Poisson distribution, whatever it is required, because unless we don't have any lambda value, we are not going further. So the value of lambda is found out, okay, using the simple probability functions. So probability function, we are trying to go for extending or solving. So the theoretical probability and theoretical frequency are calculated. Theoretical, which is nothing but expected frequency. So whatever which is given in the question under discrete X series value and frequency is given, no doubt which is the observation frequency is given. So using the observation frequency, we try to go for next step called for probability mass function. So after getting a probability mass functions value from the 0 to n numbers, okay, so we are try to go for multiply with the n value and theoretical. Finally, a table of observation, which is the observation which is given, okay, in the question they can be give for x value and frequency, okay, the using x series like 1 0 1 2, okay, the frequency for example 2. So whatever which is given in the question, which is no doubt which is the observation frequency is given. Okay, in this case observation value, which is nothing but x value, observation frequency which is given in the frequency question, and theoretical frequency are written as comparison. We need to compare both the theoretical as well as observation. Note the procedure for fitting a Poisson distribution, which is similar to the binomial distribution. Okay, the similar procedure, only the mass functions, probability mass functions can be changed. Okay, it is compulsory change in the probability each and every distribution. Probability mass function formula is different. And there are 6 steps you need to follow when you try to solve or fitting the Poisson distribution. Okay, the first one, unless we don't have a lambda value, we can't do. How we are getting? Because in the question observation value is given 0 1 2 3. This is observation value and observation frequency. Okay, so observation frequency, using the information we try to calculate the x bar value, you know, because you try to calculate which is looking like a discrete group data x and f, if you multiply you are getting fx. Okay, you know the formula for arithmetic mean formula, sigma fx divided by n. Okay, so if you simplify here, nothing but x is an observed value and f is a frequency, observation frequency you can say. Okay, now n is equal to what in the formula arithmetic mean, n is nothing but the total frequency whatever it is given, so which is always capital letter N. So going for the next step, equate the observation mean value to the theoretical mean of the Poisson distribution, that is nothing but your x bar. After calculating, after simplifying, we are getting x bar value which is nothing but lambda or np. Okay, so moving for third step, find the p of 0, because which is starting from the x observation value which is 0. So that's what we are trying to go for the mass function. So probability of p of 0. Okay, e to the power of minus lambda, which is a constant value for all the x value. Okay, so the theoretical frequency x is equal to 0, because the Poisson variant we need to select. Okay, so using Poisson probability mass function, which is nothing but a discrete random variable, p of x is equal to 0. So the formula you know, e to the power of minus lambda, lambda to the power of x divided by x factorial. In this case 0 we are directly writing, so which is Poisson variant. Next, find the theoretical frequency. We are nothing but your expected frequency, both are same. Okay, so using a x value, you need to we need to find out each and every x value, p of x value. So after getting this value, you need to multiply the capital letter N, whatever it is given in the question. Okay, now whatever, after calculating fourth step, we need to go for round of the theoretical frequency, because we need to get the N is observation frequency N. If you want to get exactly in the observation frequency, assume here 100, after calculating theoretical frequency, you need to get 100. Okay, so that's what we need to go for the exact round of value. Okay, whole numbers we are considering, the two whole number, so that the theoretical frequency always equal to 0. In the observation frequency also getting same and theoretical frequency also getting same, then there is no problem you are finding, because your both side we are getting. Okay, observation frequency and expected frequency both are you want to get same. So after fifth step, try to go for sixth step, write both observation frequency and theoretical frequency in a table, so that the comparisons can be easily made. So for that reason, the consolidated table only we are trying to solve the problem, easily we can compare. Okay, moving for there is one question, fitting the following table show that the number of customers returning, number of customer returning, which is the best example for Poisson distribution examples. So with the help of question, with the help of examples only, we can decide which is related to the Poisson distribution. So sometimes they will specify fit the suitable distribution. So we can clearly we can say which is related to the Poisson distribution. Returning the product in their marketing territory, the data pertains to 100 store. Here the x value is given, the frequency is given, the x value which is nothing but 0 to 6, which is a Poisson variant. Okay, now the observation frequency, or you can say the x value is the observation value, observation frequency, which is given in the question. Using the whatever the given information, we need to fit the Poisson distribution. Sometimes they will specify fit a suitable distribution, because seeing the examples only we can decide which is a Poisson distribution, because the returning, okay, see whatever the information, we need to construct the table. For that reason we need to identify the value for lambda. So the lambda, which is always is equal to x bar, or you can write like this NP. So further if you try to extend the x bar value, the formula is very simple. So which is given in the question, observation value and observation frequency. Observation frequency, if you take the total, you are getting 100. So using the formula base, now we are trying to go for constructing one more table. Okay, so f into x, if you multiply 0 into 4 0, 14 into 1 14, 23 into 2 46, 23 into 3 90, 69, 18 into 4 72, 9 into 5 45, 6 into 9 54. If you take the total, we are getting 300. Now easily we can find out the lambda value, because which is always equal to x bar. Calculate the mean using the formula. We got the value for sigma fx value 300. N is the frequency total, we are getting 100. If you simplify the lambda value, we are getting for 3. Okay, now moving for the next where E value is nothing but 2.7183. We know the value for E value, which is a constant value. Okay, so using this constant value, we can go for a power, we can take the power value. So lambda value, we got the value 3. So that's what e to the power of minus lambda. So we can write, we know the value for E 2.7183 to the power lambda place, we are writing just for minus 3, because we got the value for lambda. So here the reciprocal of this, since lambda is obtained, the calculate of e to the power of minus lambda. So here E value is always constant for 2.71833, okay, or to the power 3. So reciprocal of this. So how we are writing, if you try to solve manually, so 1 divided by 2.7383, okay. So if you 3 times multiply, we are getting 20. If you divide, we are getting the total lambda value minus 2 lambda, we are getting 0.04979, which is a manual calculation. Okay, now you can use for scientific calci, or you can refer for the tables, Poisson distribution table. So here whatever the given information, I cannot completely solving, because I took only for the up to 3, 0 to 3 Poisson variant I have selected. So the respected frequency I have written, the probability mass function for which is starting from the observation value 0. So e to the power of minus lambda place, we know the value for lambda minus 3, 3 lambda place. Lambda place we are writing 3, x place, because we consider we are trying to go for 0. So x value 0, 0 factorial. So anything power 1, okay, anything 3 to the power of 0 means always 1. So that's what the constant value we can write for all the variants. So the constant value, it won't change for anything. So the first value, if you simplify, we are getting 0.04979. Okay, so to find out the expected frequency, we need to multiply the capital letter N. N is nothing but observation frequency total, whichever whatever it is given in the question. So in this case 100, if you multiply, we are getting 4.98. If you try to write in the approximate whole number, we can write like this 5. Okay, so moving for the next variant 1, so which is a constant value. So we are writing constant value for all Poisson variant. So 3 to the power of 1 means we are writing 3. 1 factorial means 1. If you multiply, we are getting 0.14937. Okay. So each and every, whenever you are solving, what numbers you consider, 5 digit, 4 digit. So that is very important here. So here you can take for 4 numbers or 5 numbers, any numbers you can take. Okay. Or whole numbers also you can write. So after simplification, after multiply, you have to go for the whole numbers. Okay. Round figure, round value. Now moving for the next variant, which is 2 value, e to the power of minus 3 lambda, it's a constant value. So that's what we are writing for all situation. 3 to the power of 2, x place we are writing 3, lambda value is a standard value. So 3 into 3, 9, and 2 factorial means we have to go for reverse. Okay, in this case, we cannot simplify directly. So first we need to multiply numerator and denominator. Okay, so once you simplify, your answer will be 0.22405. Once you get the p of x value, immediately we need to multiply the frequency total n. Okay, after multiply, we are getting 14 and 22. The same procedures will follow for the 3. Okay, the same thing, 3 into 3 times multiply means 27. The 3 factorial we are extending like this. Okay, so directly 3 ones are 3 nines are. Okay, so here direct multiplication, 9 is left, so we are writing as it is, and 9 is divided by which is cancelled here, 3, because we have simplified. So 2 into 1, if you multiply together, we are getting this much divided by denominator value. So final answer we are getting 0.22405. After multiply with the n, we are getting 22.41. Okay, moving for the next variant, fourth. The frequency total, we know observation frequency total 100. The probability mass function x plus we are writing 4. So e to the power of minus lambda again and again, which is the same constant value, e to 3 to the power of 4 times. Okay, so 4 times multiply, 3 into 3 into 3, 4 time multiply means 81, getting 4 factorial. Okay, so easily we can see 3 ones the simply 3 ones 327s, 327s, whatever it is left we are writing numerator, the 27 we are writing denominator, already 3 we consider, so we are writing 4 into 2 into 1. So after multiply we are getting this much, divided by 8 if you do. How? Okay, if you divided by 8, so the final p of x value or the p of 4 value we are getting 0.16804. After multiply n frequency total, we are getting 16.80. So next 5, the same thing, p of 5, the same thing, e to the power of minus lambda constant value, 3 is 5 times multiply, 243 we are getting. So the 5 factorial we are extending like this. Okay, if you try to go for simplifying, 3 ones are 381s and 5 factor, whatever it is cancelled, remaining rest of the things we are writing as it is. If you multiply, okay, numerator we are getting and denominator we are getting 40. So after simplifying, divided, we are getting this value. After that, immediately you have to go for n value. The same procedures will follow for the last variant, p of 0, p of x plus 6, e to the power of minus c constant value, and 6 time multiply 721, 3 ones 3 4 240, 4 43s. Okay, so rest of the things we are writing because 3 is considered. After multiply we are getting 12 divided by 240. Now we are getting p of x value 0.05041. After multiply n, we are getting this one. So if you take the observation frequency total also, we are getting 100, and expected frequency also we are getting 100. Okay, keep on watch for next section. Thank you.